Hi, this is the 8th lesson in electricity. In this lesson, I'm going to discuss few exam style questions. Some of those questions, the similar questions appeared in the Edexcel or Cambridge past papers. Okay, this is the first question, a simple question. This is a real cell connected to a bulb. The resistance of the bulb is 15 ohms. So first part, find the current through the bulb. Okay, so to find the current through the bulb, we should find the total resistance of the circuit. So that I can say R0, you know they are in series, no junction, no branches. So R0 will be 15 plus 1, that is 16 ohms. So current I is equal to EMF over total resistance, that will be 12 over 16, so 0.75 amperes. Okay, second part. Find the terminal potential difference of the cell. Okay, terminal potential difference, I explained that in my 7th lesson. So potential across the two terminals of the power supply. So if I think that way, I can use V equal E minus IR. So EMF we know 12 volt minus current is 0.75 into resistance 1. So that will be 11.25 volt. Or I can find like this in this circuit. You know the terminal potential difference means voltage across the terminals. That will be same as the voltage across the bulb. So I can use V equal IR for the bulb. So that will be equal to current 0.75 into 15. You will get the same answer, 11.25 volt. Okay, third part, find the power generated by the cell. So power generated by the cell is given by P equal EMF times I. So the EMF is 12 into current is 0.75. So it will be 9 watts. That's the power generated by the cell. Last part, find the efficiency. So efficiency means efficiency of transferring power to the bulb, right? So we can say power transferred to bulb or power dissipated in the bulb. That I can say I squared R. So that will be 0.75 squared into the resistance of the bulb 15. That will be 8.44 watts. So efficiency of the bulb power supply in this circuit will be useful output is 8.44 over power generated is 9 into 100%. So that will be 93.8%. Okay, so this is the second question. A real cell that has EMF 16 volt and internal resistance R. There are two bulbs B1, B2 connected in parallel. So their resistance are given 20 ohms and 10 ohms. And the resistor is connected in series with combination of these two bulbs that has resistance 12 ohms. Find the voltage across B2. Okay, that's the first part. So to find the voltage across B2, I don't know the current through B2, but I know the current through B1. I know the resistance of B1. So I can find the voltage across B1 by using V equal IR for the bulb B1. Then B1 and B2 are in parallel among them. So the voltage across B1 will be equal to voltage across B2. So I'll find the voltage across B1 first. I can use V equal IR for B1. So the current is 0.25 amperes into resistance is 20. So it's going to be 5 volt. So voltage across B2 also the same because they are parallel. That also 5 volt because they are parallel among them. Second part, find the current through the cell. So find the current through the cell means, you know the current through the cell. If I take I, so here through this 0.25, through this I can say I2. So I is equal to 0.25 plus I2 according to Kirchhoff's first law. Is it? So I need to find the I2. If I find the I2, then I is equal to I2 plus 0.25. So I can use V equal IR for V2. I know the voltage across it 5 volt. I need to find the I2. The resistance is 10 ohms. So I2 will be 0.5 amperes. So current through the cell is I. I know that I is equal to I2 plus 0.25. So I2 is already, we know that 0.5 plus 0.25, that will be 0.75 amperes. So that's the current through the cell. Third part, find the terminal potential difference of the cell. So normally we use V equal E minus IR, that is given in the data sheet. But here I can't use that because I don't know the internal resistance of the cell. But I know the voltage across the cell, the terminals of the cell is called terminal potential difference. Voltage across the terminals of the cell is called terminal potential difference. That will be the total voltage or sum of the voltage, the addition of the voltage across 12 ohm and the junction. So I can find the voltage across 12 ohm by using V equal IR. I know the current through the 12 ohm, that is 0.75 into 12 is the voltage across 12 ohm resistor. And the voltage across the junction is same as voltage across either V1 or V2. That also we know that already, that is 5 volt. Is it? So I can find the terminal potential difference. So first I will find the voltage across 12 ohms. 12 ohm resistor. So that will be 0.75 into 12. So that will be 9 volt. Then I need to find the terminal potential difference. I'll continue here. So terminal potential difference equal the voltage across 12 ohms, that is 9 volt, plus the voltage across the junction, which is 5 volt. So that will be 14 volt. Last part, find the internal resistance of the cell. So last part, I can use V equal E minus IR. Since I know the terminal potential difference, I already found it, which is 14 volt. EMF 60 minus the current is 0. The current through the cell is 0.75 amperes. I found it already. R. So find the R. So 0.75 R equal 16 minus 14, 2. Find the R. So that is 2.67 ohms. Okay, this is the third question, slightly different type, about battery charger and a cell. You know, when you are charging a battery or when you are charging a cell, the current will come out of the charger and goes or flows into the cell. So current should come out of the charger and flows into the cell. Normally, when you are using the cell, current will come out. When you are using this cell in a circuit without charger, when you use the cell in a circuit, current will come out through the positive terminal of the cell. But when you are charging the cell, a rechargeable cell, the current will flow into the cell. So the EMF of the charger must be more than the EMF of the cell. But both will have the same terminal potential difference. Terminal potential difference across the charger will be same as the terminal potential difference across the cell, because if you connect a voltmeter here, it will read the terminal potential difference of the charger, but wire has no resistance, so that means it will read the terminal potential difference of the cell as well, right? So terminal potential difference of the charger will be same as terminal potential difference of the cell. Right, first part, find the current flow through the cell. So here, you know, the positive terminal of the charger and the positive terminal of the cell are connected together. So they are not in series. The charger and the cell are not connected in series. So for example, if you connect two cells like this, that means if the EMF of this one is 6 volt and this is 4 volt, then the total EMF will be 10 volt. But if you connect the other way, this is positive, negative, negative, positive. If you connect it the other way, the total EMF in the circuit will be 6 minus 4, that will be 2 volt. Okay, so here also the same way they are connected. The positive terminal is connected to positive terminal. So the total EMF in this closed circuit will be 16 minus 12, that will be 4 volt. So total EMF will be 16 minus 12, that will be 4 volt. So in this closed loop, the total EMF will be 4 volt. Total resistance is 2 plus 4, 6. So EMF is equal to I times the total resistance. So 4 equal I times total resistance is 2 plus 4, 6. So I will be 4 over 6. That is 4 over 6 means 2 over 3, 0.67 amperes. Okay, second part, find the terminal potential difference of the cell. So we know that V equal E minus IR whenever we are using a cell to supply power to a circuit. But here the current is going into the positive terminal. We can use V equal E minus IR when current comes out of a positive terminal. So when you consider a circuit, a cell something like this, which has resistance R and the EMF is epsilon and it's connected in a circuit, current will come out of the cell. So there I can say the terminal potential difference equal V equal E minus IR. But here current is going into the cell. So I can't use this equation. We can use it as V equal E plus IR, but that equation is not in the Edexcel syllabus. So how can we find the terminal potential difference of the cell? I already told that terminal potential difference of the cell is same as terminal potential difference of the charger. But for the charger, current is coming out of the charger. Current is coming out of the positive terminal of the charger. So I can use the same equation V equal E minus IR. For the charger, that terminal potential difference will be same as for the cell also. So use V equal E minus IR for the charger. So V equal EMF is 16 minus I is 0.67 times into resistance 2. Solve it. That will be the terminal potential difference of the charger. That will be 14.66 volt. So terminal potential difference of the cell also the same, 14.6 is. Or you can use V equal E plus IR because current is going into the positive terminal. But that equation is not introduced in Edexcel and Cambridge syllabuses. But if you want, you can use it like this. V equal E plus IR plus, not minus, because current is going into the positive terminal. For the cell, you will get the same answer. So EMF of the cell is 12 plus current is 0.67 into resistance of the cell, that is 4. You will get the same answer. Slightly it might vary because of the approximation in the current. So 14.66 or 67 you might get it. But normally we don't use this in Edexcel or Cambridge syllabus. Okay, third part, find the power generated by the charger. That we know that power generated by the charger, EMF times EMF of the charger into current through it. EMF of the charger is 16 volt into current through it is 0.67 ampere. Solve it, you'll get the power generated. That will be 10.72 watts. Okay, fourth part, find the total power loss in the circuit. So total power loss in the circuit is due to the internal resistance of both the charger and the cell. So total power loss equal I squared R1 plus I squared R2. R1, R2 are the internal resistance of the charger as well as cell. So I squared, I can take common. So I squared will be 0.67 squared into R1 is 2 plus 4. So that will be 2.69 watts. So last part, find the efficiency of the charge when EMF of the cell is 12 volt. So efficiency, I know the total power generated, I know the total power wasted. So power transferred to the cell, that will be total power generated minus power wastage. So that will be 8.03 watts. So efficiency, power transferred divided power generated by the cell, 10.72 into 100%. So that will be 74.9%. Okay, so this is the fourth question. A real cell, its EMF is epsilon and internal resistance is R, connected to a circuit. Voltmeter is ideal because that means it has no current flow through it. That is, its internal resistance is very large. Same way, ammeter also ideal. So S is the switch. When S is closed, voltmeter reading is, so when S is closed, voltmeter reading is 11.2 volt. And when S is opened, voltmeter reading is 12 volt. First part, determine the EMF of the cell. Okay, so when S is closed, what will happen? When S is closed, that means when I close the switch S, no current flow through the voltmeter because its internal resistance is very large. So current flowing through the cell will flow through the 10 ohm resistor. So the voltage across the 10 ohm resistor is same as the terminal potential difference. Voltmeter is reading the terminal potential difference as well as the voltage across the 10 ohm resistor. And when S is closed, the voltmeter reading is 11.2 volt. That is the terminal potential difference of the cell. That will be same as voltage across 10 ohm resistor also. But when S is open, that means there won't be any current flow because current flow through the voltmeter is negligible because its internal resistance is very large. So when S is open, there is no current flow through the cell. So when there is no current flow through the cell, what will happen? The voltage across the cell will be equal to EMF. So we can say the first part answer, when S is open, I can say no current flow through the cell. So I can say terminal potential difference of the cell, which is read by the, that value is, the voltmeter is reading it, P equal E minus IR, where I is equal to 0. So that means V is equal to EMF. But V is recorded by the voltmeter as 12 volt. But reads the terminal potential difference which is 12 volt. V is 12 volt. Therefore, EMF is also 12 volt. That's the first part answer. Second part answer. Find the ammeter reading when S is closed. So when S is closed, we know the terminal potential difference, that is 11.2 volt. That is the voltage across 10 ohms also. When S is closed, I can say when S is closed, the current flowing through the cell will flow through the 10 ohm resistor, and that will be the current flow through the ammeter also. So I can use V equal IR for 10 ohm resistor. So I know the voltage 11.2. Current is the question. I need to find it. That's the ammeter reading. I need to find it. And the resistance is 10 ohms. So I will be 1.12 ampere. Third part, find the internal resistance of the cell. Now I can use V equal E minus IR, the standard equation for the cell. I know the terminal potential difference when there is current flow, that is 11.2. EMF is the 12. We found it already first part. Minus I is 1.12 times R. I need to find the R. So 1.12 R equal 12 minus 11.2, that is 0.8. Find the R. That is 0.71 ohms. Okay, so this question, normally in all my previous questions, we consider the connecting wires have no resistance. But here in this question, it says that the total resistance of the connecting wires is 6 ohms. First part, find the terminal potential difference of the cell. Okay, so you should understand like this. The current which is flowing through the cell and motor will also flow through all part of the wires. So the total resistance of the wire is in series with the resistance of the motor as well as internal resistance of the cell. So I can redraw the same circuit like this by showing the total resistance of the wires as a resistor. Then I can imagine the wire as resistanceless wires. I can imagine the same circuit. I can redraw the same circuit like this. This is 2 ohms, 9 volt. And you can show the resistance of the wires as a resistor like 6 ohms. Then imagine these wires have no resistance. Easy to handle this type of questions. So resistance of the motor is 10 ohms. So because the reason I put the resistance of the wires separately as a resistor, the reason is it's in series. The wires are connected in series. The total resistance of the wire will be in series with all other resistance of the components like cell and the motor. So now I can imagine these connecting wires have no resistance because I showed the resistance of the wires separately. Okay, now you know how to handle this type of question. Find the terminal potential difference. So I need to find the current first. So we'll find the current first. I can use I is equal to EMF over total resistance, that is 9 over total resistance 6 plus 10 plus 2, that will be 9 over 18, 0.5 amperes. So terminal potential difference, we equal E minus IR for the cell. I know the EMF 9 minus 0.5 into the internal resistance 2 ohms. So it's going to be 8 volt. Second part, find the total power loss in the circuit. So total power loss will be in the connecting wires and the internal resistance. Total power loss, the power wastage. So here we don't say the total power loss in the circuit. So total power loss in the circuit means unwantedly we are losing power. Anyway, motor has its power. Anyway, it needs power for that. So the total power loss in the circuit will be power loss in the internal resistance as well as power loss in the connecting wires. Circuit, that will be I squared. These are power wasted. They are going to be converted to heat, right? I squared into 2 plus 6. So current we found it 0.5 squared into 8. That will be 2 watts. Third part, find the efficiency of the circuit in transferring power to the motor. So third part, I can find the power transfer to the motor, P equal I squared R. That is 0.5 squared into 10. That is 2.5. That will be 2.5 watts. So efficiency of the circuit, useful power output to the motor is 2.5. I need to find the power generated by the cell. So power generated by the cell, I need to find it. That will be power generated by the cell EMF times I. So the EMF is 9 into 0.5, that is 4.5 watts. So efficiency 2.5 over 4.5 into 100%. 55.6%. So here I found the power transfer to motor by using I squared R, 2.5, I got it. Or you can find like this, total power generated is 4.5. Power wastage in the circuit is 2. So 4.5 minus 2 is equal to 2.5. That way also you can find the power transfer to the motor. But I found it directly by using I squared R. If you want, you can find total power generated minus total power wastage in the circuit due to the internal resistance of the cell and the resistance of the connecting wires. So you will get 4.5 minus 2, that is 2.5. So 2.5 over 4.5. But I found the power transfer to the motor by using I squared R. Anyway, you will get the same answer. Okay, so in this question, there's a real cell which has EMF epsilon and internal resistance is R. There's ammeter or milliammeter, whatever it is. Now they are saying when the value of this is a variable resistor, when the value of R is 12 ohms, the reading of the milliammeter is 107 milliamperes. So when this circuit is switched on for 5 minutes, that means 5 into 60, 300 seconds, the total energy transferred by the cell to the circuit is 50 joules. So first part, find the value of EMF and the internal resistance of the cell. Okay, you know that energy transferred by the cell, power transferred or power generated by the cell is equal to EMF times I. If you multiply the power by the time, you will get the energy. So first part, I can say power generated by the cell equal EMF times I. So what is the energy generated by the cell during time t? Energy transferred by the cell or energy generated by the cell? Energy generated by the cell or energy transferred by the cell? During time t is equal to power into time, that is EMF I into t. So this total energy is given as 50 joules and I know the current. So I can say EMF I into T is equal to 50 joules. EMF I need to find. Current I know 107 milliamperes. So 107 into 10 to the power minus 3 amperes into time is 5 minutes. So 5 into 60, that is 300, equal to 50. Find the EMF. So that will be 1.56 volt. Okay, so the next part, the same question, this next part, find the internal resistance R. Okay, so I can find it in different ways. I can find the voltage across capital R by using V equal IR, that is the terminal potential difference. I can use that way. So different methods I can follow. So I can use like this, use V equal IR for capital R, which is 12 ohms. They are saying it's 12 ohms. So that will be 107 milliampere means 0.107 into 12. That's the terminal potential difference. So find that value. So that will be 1.284. So I can use V. So that's the voltage across 12 ohm resistor, that is capital R. That will be the terminal potential difference. So I can use V equal E minus IR. So 1.284 equal EMF, we found it 1.56 minus current, we know 107 milliampere means 0.107 amperes into R. So find the value of R. So that will be 2.58. Or you can do the same thing by using EMF equal Kirchhoff's second law. EMF equal IR plus IR. So EMF we know that 1.56 equal current, I can take it common, that is 0.107 into R is 12 plus similar. So find the value of 12 plus R equal 1.56 divided by 0.107. Find it and hence find the similar. That will be 14.58. So R will be 14.58 minus 12, so 2.58 ohms. Same answer, you get it. Either way you can do. Okay, second part, increasing R. R is the variable resistor. Increasing R would make the terminal potential difference value closer to EMF. Explain why. So simple, you can say when capital R is increased, the total resistance of the circuit will increase. Is it? When capital R is increased, total resistance of the circuit is given by R plus R. So the current flow will decrease R plus R. So you can say when R is increased, I will decrease, current flow will decrease. So terminal potential difference is given by V equal E minus IR. So when I decreases and when I becomes very small, almost equal to 0, IR will become equal to 0. So I can say when I becomes almost equal to 0, then V will be equal to EMF minus a 0. That will be equal to EMF. Okay, so in this circuit, two bulbs A and B are rated. Bulb A is rated as 12 volt 60 watts and B is rated as 12 volt 30 watts. So first you should know what is meant by rated. That means if the voltage applied across bulb is 12 volt, then it will consume 60 watts of electrical power and dissipate totally light and heat that will be equal to 60 watts. The bulb B is rated as 12 volt 30 W. That means if the voltage across B is 12 volt, then it will consume every second 30 joules of electrical energy, or it will consume 30 watts of electrical power and dissipate totally 30 watts of light and heat. If the applied voltage is less than 12 volt, then it will consume a power which is less than 60 watts. For A, I am saying, if the voltage across A is less than 12 volt, then it will consume less than 60 watts. So it will be dimmer. If the applied voltage is more than 12 volt, what will happen? It will burst, or the filament will burn, right? If the voltage applied across it is more than 12 volt, that means the filament might burn. So normal condition means in a circuit, if a component is in normal condition, means in that circuit, that component is getting the required voltage. So here, these two bulbs are connected in series, and the student says that both bulbs will operate normally. That means the student says that this bulb will get 12 volt and the power output from this bulb will be 60 watts. This bulb will get 12 volt and the power output will be 30 watts. So the question is, evaluate whether the student's statement is correct here. Okay, so what will happen in this circuit? Now they are connected in series, so we will see what will be the resistance of bulb A. So I can say for A, I can use P equal, I'm going to find the resistance P equal V squared over R. So its power is 60, its voltage when it is 12, what will be its resistance? So what's the resistance of the bulb? I can find it. 12 square divided by 60, that will be 2.5 ohms, 2.4 ohms for A. Similarly for B, if I find it, RB will be equal to, the voltage across it will be 12 squared, its power is 30, so that will be 12 squared divided by 30, that will be 4.8 ohms. Now look at here, here's the problem starting, because they are connected in series, right? So the resistance of this bulb is 2.5 ohms and the resistance of this bulb is 4.8 ohms. You know, in series connection, the total applied voltage will be divided across them according to the ratio of their resistance. So the 24 volt will not be divided across them equally as 12 and 12. It will be divided at the ratio of 2.4 is to 4.8. That means the voltage across B will be almost is twice the voltage across A. So bulb A will get a voltage which is lower than 12 volt and bulb B will get a voltage which is more than 12 volt. So bulb B might get fuse and bulb A also will not function because the voltage across it is lower than 12 volt. The answer, I can say, we can do a calculation. So the answer should include these calculations. Then you should say in series connection, voltage will be divided at the ratio of their resistance. So you can give the answer like this. Better do a calculation because they are asking evaluate whether the statement is correct. So you need to do some mathematical evidence because they have given the total voltage and the how they are rated also given. So find the resistance. Then you should explain in this C connection. The connection is series. So the voltage will be divided at the ratio of their resistance. So it's going to be 1:2. So the voltage across A will be lower than 12 volt because this is 24, it won't be divided equally. If it is divided equally, 12, 12, they will get, no, that won't happen. This is going to get lower than half of that. So it will get lower than 12 volt and we will get greater than 12 volt. So both bulbs will not be in normal condition. So the statement is wrong. So how can we solve this problem? How can we keep both bulbs in normal condition? So the only possibility, we should connect them in parallel with the given DC power supply. If we connect them in the parallel, then both bulbs will be in normal connection like this. Okay, so if you connect them like this to the 12 volt power supply, both will get, so here you need to have a 12 volt, so not 24 volt. If you have a 12 volt power supply, then they will be in normal condition. So that's not the question, but you can have it like this. If you want to use both bulbs in normal condition, you should connect it to a 12 volt power supply in parallel, then they will be in normal condition, but that is not in the question. So anyway, but I just told you can connect them in parallel connection with 12 volt power supply. Okay, so we'll continue more questions in my next lesson. Bye.